In this tutorial, we're just going to talk about the basics of complex numbers. So I'll start with explaining what complex numbers are, and I'll move to other concepts as well. So one thing that you need to know is that I squared is equal to -1. So a set of complex numbers is a set of all the numbers that exist, including the imaginary ones. So it consists of a set of all real numbers plus imaginary numbers. So the form of a complex number, the symbol can be C, a C kind of like that, yeah? That's a symbol. Well, a complex number is any number that you're able to express in the form of A plus IB, okay? So this is what you need to know. So there are cases B may be equal to 0. So for all the real numbers that you know, for example, let me show you that the number 4 is also a complex number, in that you're able to express it as 4 plus I0. So it is still a complex number. So all the numbers that you know that exist are complex numbers. So complex number is the biggest set of numbers. Okay. Now that you know what a complex number is, you need to know that when you look at the form of a complex number, which we are calling A plus IB, the A part is called the real part because it does exist, and then the I part is called the imaginary part. Okay. So you and I know that you can't find the square root of a negative. Okay, it's quite impossible. Well, under complex numbers, that's not the case. So I'll show you what I mean by that. So let's move. So I want you to know, for all the questions we're going to look at, that I squared is equal to -1. If you try to make I, if you try to find I, you find the square root on both sides, you're going to find that I is basically equal to the root of a -1. Okay, so two things that we know so far. You can express a complex number in the form of A plus IB. Now you now know that your I is basically equal to the root of -1, and then I squared is equal to -1. Okay, so let's move on. So using this concept that we know so far, how would you simplify things like I to the power 3, I to the power 4, I to the power 25, I to the power 100, and so on and so forth? How would you simplify that? Okay, so let me give you an example on how you can handle such questions. Of course, later on I'm going to give you several questions that you can look at, but let me give you an example, starting with the basic ones we have. Let me also include I to the power 5, okay, and I to the power 6 for basic understanding. So I to the power 3 can be expressed as the product of I times I squared. So we know that I squared is equal to -1, so we can substitute where there's I squared, we're going to put -1. So essentially we can see that I to the power 3 is the same as -I. So simplify the first one. Pause the video and try out I to the power 4. Now I to the power 4 can be expressed as I to the power 2 multiplied by I to the power 2. Or I can decide just so that as we proceed we can see it's the same as the power 2. So therefore I squared is the same as -1. -1 to the power 2 is going to be a +1. So I to the power 4 is the same as a 1. Let's move. Let's look at I to the power 5. I to the power 5 is the same as I to the power 4 and I. So it's better to deal with even numbers. So each time you've got an odd number, pull out an I, and then you remain with an even part. So the even part can be expressed as I to the power 2, and then you can pull out the 2 again, multiplied by I. Now I squared is -1 squared multiplied by I. You know that I squared, -1 squared is a +1. So the answer is essentially going to be I. What if we tried I to the power 6? How different would it be? It would even be easier. I to the power 6 would be expressed as I to the power 2 and then raised to the power 3. Now you're going to have -1 to the power 3. Now what happens if you multiply a negative number by odd number times? So in this case it's going to be a -1. Okay, so each time you've got a negative being raised to an even power, if it's 100 or 1000, it's going to be a +1. If you're going to have it as 101, which is an odd number, it's going to be a negative. And I think that's one thing that's very important when it comes to simplifying all these. So we're now doing the last two. So we have I to the power 25. We can put an I so that we can remain with an even power. So we have I, and then that can be as, can have I squared inside, and then you can pour out 12. 12 times 2 is 24. So we know that what we have in the brackets is a -1, and then raise the power up 12, which is an even power, so it's going to be a positive, so it remains I to the power 100 is an even number, an even power, so it's going to be I squared directly. I squared raised to the power 50. 50 is an even number, so -1 to the power 50 is going to be a +1. So clearly you now know how to simplify these complex numbers faster and simpler. Okay, now let's look at the addition, subtraction, multiplication, and addition of complex numbers. Division, everything is going to be covered just right here. Okay, now consider a case where you're trying to add complex numbers 2 plus 4i plus 6 plus 2i. So one thing that you need to know is this is the same case. Even when they say let your a be equal to 2 plus 4i, and then they say let your b be equal to 6 plus 2i, and then they ask you to find a plus b, it's the same question. Whether it's given like that or given in this other form, it's still the same. So how do you handle it? How do you handle such a question? So for addition and subtraction, correct the like terms. So in this case, the real part we have 2 and 6. So 2 plus 6. And then the imaginary part we have 4i plus 2i. So therefore we have 8 plus 6i. 2 plus 6 is 8. 4 plus 2 is 6i. So that's how you add complex numbers. Let me change a few things so that I can have negatives as well, and then we see how we can add them. So let our a be equal to -3 minus 2i, and then let our b, of course, let's have -2, and then plus 4i. How do you add those complex numbers? So we're going to have -3 minus 2i, and then plus -2 plus 4i. Okay, so all the same we have to correct the like terms. So for the real part we have -3, and then plus -2, it will remain -2, and then minus 2i plus 4i. So for the real part, this is going to be a -5. -2 plus 4i, that's the same as 4 minus 2, which is going to be plus 2i. So that's how you add complex numbers. So we've looked at the addition part. Let's look at the subtraction. What happens if we were trying to find the difference? How different would we handle it? So if we're going to subtract, if we're told to find a minus b, this is basically how you would handle it. It's going to be equal to that, because what you're doing is subtracting. So therefore we're going to have -3 minus 2i. So distribute the negative there. You have to be very careful. So that's going to be a positive 2i. No, just +2, and then that's going to be a minus 4i. So after you've distributed the negative, you now have to correct the like terms. So we have -3 plus 2, and then we have -2i plus or minus 4i. So you're going to have a -1 if you look at that, and then you're going to have a -6i after you look at, okay? So that's what we have there, -1 minus 6i. So we've looked at both addition and subtraction. Same concept applies. Just collect the like terms, know how to distribute the negative, and so on and so forth. And then I can just give you one more practice questions. One practice question actually. Yeah, on the subtraction aspect. So consider a case where we have 2 plus 3i, and then 5 minus 2i. So I'll actually use the same examples for, let's say I have 4 minus 2. I'll use the same examples for multiplication and division. How do you handle this question when you're told to subtract? Let's say you are to be given b minus a. So it means start with b, which would mean 4 minus 2i, and then subtract a, which is a plus 3i. So all the same, how is it a plus 3i? It's 2 plus 3i. Okay, so we're going to have 4 minus 2i, and then we distribute the negative, so we have minus 2 minus 3i after we've distributed the negative. The like terms, we have 4 minus 2, which is essentially a 2. Then negative 2i and minus 3i, that's going to be a minus 5i. So that's how we subtract and add complex numbers. The addition and subtraction deals with the like terms. Like terms, yeah. Okay, now this part becomes important. The I squared being equal to negative 1 becomes important when you begin looking at multiplication and division, as you see. Let's start with multiplication. So let's say we want you to find the product of A and B, or AB. How would you go about it? Or if you just put the brackets 2 plus 3i multiplied by 4 minus 2i. How would you handle it? So the same way you know how to multiply. So I'll first of all pick the 2 and then multiply the other bracket. So 2 times 4 minus 2i, and then we have to multiply by the 3 now, 3i. So plus 3i, and then multiply by 4 minus 2i as well. So let's do it. The same way we multiply quadratics. Okay, so 2 times 4 is going to be 8 minus 4i. 3i multiplied by that, we're going to have 12i minus 6. Now I times I is going to be I squared. 8. So we can see that these are like terms. Negative 4 plus 12 is going to be a plus 8i. And then negative 6i squared. So negative 6. Now I squared, we know it's already equal to negative 1. Now this is where I'm saying that's important. So we've just distributed, and then you're going to have 8. Negative 6 times negative 1 is going to be a plus 6. Now don't forget about the 8i that's there. So I've already corrected the like terms in advance. Okay, because this is going to give us 8 plus 8i and then plus 6. So correcting like terms, we have 8 plus 6 and then plus 8i. 8 plus 6 is going to be a 14 plus 8i. So that's how you multiply complex numbers. The same way you know how to multiply different things in the bracket, that's the same way you're supposed to handle it under this part. Okay, now how would we handle it if we had maybe negatives or something? Same way. So even if we say let our a be equal to 1 minus I, and then maybe b to be negative 2 minus maybe I, how would you expect it to come out? So you would basically see that 1 minus I multiplied by negative 2 minus I. So let's start with 1, multiply that, it's going to be negative 2 minus I, multiplied by negative I, it's going to be minus 2. In fact, it's going to become positive now because of a negative. So the negative I, multiply that bracket, so that is going to be plus 2I and then plus I squared because of a negative times negative. So I have negative 2 minus, now negative I plus 2I is just essentially I squared is negative 1, so I have negative 3 plus I. Okay, that's how funny complex numbers are in themselves. Now let's look at division. Let's look at division and see what we're going to have. Consider a case where they want you to find A divided by B. How do you go about it? So how would that look like? That would appear to be 2 plus 3i divided by 4 minus 2i, right? So we are dividing here. What does it mean? We're dividing, multiply by the conjugate. So 4 plus 2i, and then multiply by 4 plus 2i, right? That's what we're doing there. How do we go about it? So it's going to be a bit tricky. There's nothing tricky. Now there's one concept that I've not explained. So this part, we call it the conjugate. Okay, so each time you're dividing, multiply by what you call the conjugate. So the conjugate implies you change the sign of the middle part, so it's the imaginary part if you want, but anyway it works. So just change the sign in between. So that's what we've done. There are some cases where this question may be asked differently. They may give you such a question, or They may give you any kind of an expression in terms of fraction and then ask you to express it in the form of a plus ib, where a and b are real numbers. So you actually get to approach it in the same manner. Okay, so let's go on and multiply this. So for the top part, we'll multiply. That's why we had to learn multiplication before looking at the division, because it's involved in division. So 2 times whatever we have there. So 2 times 4 is going to be 8 plus 4i. We've multiplied by 2. Let's now multiply by the 3i. 3i times 4 is going to be 12i. 3i times 2i is going to be 6i squared. Divided by... Now, this is where it's interesting. Now, multiplying a complex number with its conjugate. 4 times 4 is 16. Right? Now, 4 multiplied by 2i is going to be 8i. Now, the negative 2i plus multiplied by 4 is going to be a minus 8i. Negative 2i times that is going to be a minus 4i squared. So, this always happens when you are multiplying a complex number by its conjugate. The middle part is always going to cancel out. So, essentially, what's important is just to multiply the like parts. Multiply the real part by the real part. So 4 times 4 and negative 2i by 2i. Each time you're multiplying a complex number by its conjugate. Don't waste time. So you're just going to have 16 minus 4i squared. Now I squared, we know it's a negative 1. So this is where that is very important. So by the way, this part is a 0. Okay, just in case you're wondering why it's cancelled. So we have... So where we have I squared on the 6i squared on top, we can put a negative 1 as well. So we have 8, 4 plus 12 is 16i, and then minus 6 over 16 plus a 4. So what do we have? 8 minus 6 is a 2, so 2 plus 16i over 20, which we can now simplify beyond that point and say divide by 20. So I'm going to have 2 over 20 plus 16i over 20. So that's 1 over 10 plus 4i over 5. So you've expressed it in the form of a plus ib. So that's how you divide complex numbers. Very easy to underwrite. Let me give you one more and see what we're going to have. Now this one is going to be a derivative move. Let's have 4 plus 6i. So let's find b over a. So our b is 4 plus 6i, and then our a is 2 plus 3i. So you can somehow see it's like b is like twice that of a, right? From what you're seeing. So to divide, multiply by the conjugate of the denominator. The conjugate of the denominator in this case is changing the sign, 2 minus 3i. Do the same to the numerator. Okay? So let's see what we can have. We'll start with 4. 4 multiply everything on top. 4 times 2 is 8. That's going to be 12i after multiplying by negative 3. 6i times that is going to be a 12i. Surprisingly. Yeah, and then 6i times that is going to be a minus 18i squared. Over 2 times 2 is going to be a 4. I said for the conjugate part only multiply the like parts, and then 3 times negative 3 is going to be a minus 9, then I squared. So you have 8. This part is eliminated as well. You're going to have 8 minus 18. Now I squared is negative 1 over 4 minus 9. I squared is negative 1 as well. So you're going to have 8 plus 18 over 4 plus 9. 18 plus 8 is a 26. 4 plus 9 is a 13, which is essentially twice. So you can actually see that the division of complex numbers is actually true, proven by the example we've looked at, right? So now looking at our basics of complex numbers so far, we've looked at the most important aspects of it. addition, subtraction, addition, division, multiplication. I've also given you the form of the complex number to be a plus ib. Now let's look at the part of it that involves sketching. How do you graph a complex number? So it's as simple as you knowing the fact that the y-axis is the imaginary part and then the x is the real part. So this is going to be the I, and then that's the real part. Okay, so if I'm going to have a complex number 2 plus 3i, so I need to know that this is 1, that's 2, that's 3. So 1, 2, 3. So of course this side negative 1, negative 2, negative 3. All the same here, negative 1, negative 2, negative 3. Pay attention there. Okay, so the same way we know the x-axis, the x or y plane. So 1, 2, 3, 4. So if we are going to have a complex number 2 plus 3i, it's going to be 2. So the real part is on the x-axis, so that will be a 2, and then the 3i, that's on the y-axis, that part. So it is going to be there. So that complex number there, so that complex number we have, that's the way you can actually present it on the, that's how you can basically show it on the sketch. Okay, but it's better to show it this way. Draw something like this, just to show where they're coming from, and then that's a 2 plus 3i. Okay, so basically that's how the complex numbers come out when it comes to the aspect of you sketching them. Of course, I didn't mention they can be complex numbers which is just like 6i. It's a complex number on its own, so that would require you just to, it can just exist on, like 6i would mean it's just on the y-axis, right? Yeah, if it's just a 6, it's just a number like that. So equally, if it's a negative, if you have a negative 2 plus 2i, for example, so that would mean on the real part you're going on the negative aspect of it, and then of course positive 2. So that's where the complex numbers would exist. Okay, so that's negative 2 plus 2i. I think it's very easy when it comes to the sketching of complex numbers. I think all you just need is just the issue of knowing that when it comes to the x-axis, it's the real part. When it comes to the y-axis, it's now the one that involves the imaginary part of the complex number. Okay, so I've given an idea on how you could actually sketch a complex number, right? So that's where I'm going to end with introduction to the basics of complex numbers. So in the next series we're going to, in fact, before you look out for the other part, there's going to be a link in the description below to the video about the practice questions, okay, about what we've talked about so far, and then you can look at a video which is more advanced concepts of complex numbers later on.